Welcome to Study Loop.
Hi everyone. In problem 44, we are asked to find the velocity of a block as it slides on a horizontal surface and off a cylindrical surface BCD. We are given the height to be 0.9 meters and theta to be 30 degrees. And we are again asked to solve for the velocity that the block is sliding on the horizontal surface. So first we need to understand that as the block slides from this point B to the point at theta, and let's draw, we'll call this theta, work is being done. So we will apply the principle of work and energy. The work from point B to point theta is equal to the kinetic energy at point theta minus the kinetic energy at point B. So this is the main equation that we are going to be using. And now let's go ahead and expand on each of these components. So first with the work, we know that work is equal to the weight times the vertical displacement. So work equals weight times vertical displacement, which for weight, we could sub in mass times gravity times the vertical displacement. And the vertical displacement is going to be this distance here, only this distance from this vertical distance from B to point theta. So let's expand our picture to understand this a little bit better. Okay, we have our curve. And let's draw our angle. Okay, so we have the height of this to be h. And since this is a circle, the height is also the radius, so the height is the same here. And we are looking for only this vertical distance between point B and theta. So what we're going to do to solve that is we're going to take this overall, this h, minus this portion right here, which is h, because this is the radius, cosine theta. So plugging that back in, we have our work equals mass times gravity times h minus h cosine theta. Just to clarify, this is the displacement. Okay, so now let's talk about the kinetic energy at theta. Let's scroll back to the top. At theta, we have a different velocity than the velocity we're talking about when the block is moving on the horizontal surface. Since the block is moving down, the velocity is going to increase as it moves down the curve. So we're going to take the formula for kinetic energy. Kinetic energy at theta is equal to 1/2 mv squared, but this v is going to be the velocity at point theta. So again, that's different than the velocity that we're looking for in the problem. So let's expand upon this velocity to better understand that. And we will draw a free body diagram. Okay, so we have our block, and we have our angle and a normal force here, and the weight acting downwards. And again, here's our angle. So we have, we're going to use Newton's second law, F equals ma, and we need to find this force that is acting here. So if this block was at the top, you'd have your normal force going upwards and the weight downwards, and they would be equal to each other. But since this block has slid down, there's going to be less of a force acting on the surface because less of the weight is acting. So you're only going to use the component of the force. So you're going to use the weight times the cosine of this angle, which is also this angle. So you're only using this component, like to there, as your force. So we have weight cosine theta is equal to mass times acceleration. And since this is a cylinder, we're going to use the circular motion principle. So we have v squared over r, which our radius is h. So we have v, this is our velocity at theta, squared over h. And we're also going to sub mg for the weight. So we have mg cosine theta is equal to mv theta squared over h. We're going to cancel out our m's and solve for our velocity at theta. And we're going to plug that back into our kinetic energy equation. So we have kinetic energy at theta is equal to 1/2 m v squared, which is gh cosine theta. Okay, so lastly, in our principle of work and energy equation, we have to find the kinetic energy at point B. So kinetic energy at point B. And at point B, if we scroll back up to the top, we only have kinetic energy working here. So this is just our kinetic energy formula, 1/2 mv squared. And that is the velocity that we are solving for. So now we have these three equations that we expanded upon, and we're going to plug them all back into our principle of work and energy equation. So we have mg, this is our work, h minus h cosine theta is equal to our kinetic energy at theta, which is 1/2 mg h cosine theta minus our kinetic energy at point B, 1/2 mv squared. So now we just solve. So I'm going to go ahead and cancel out our mass. And I'm also going to multiply this whole thing by -2 to get everything positive and to get rid of these fractions. I'm also going to move this v squared to the left side because that's what we are solving for. So we have v squared is equal to g h cosine theta. That was this, minus 2g h minus h cosine theta. That was subtracting this to the other side. Okay. Next, I'm going to multiply this through. So we have gh cosine theta minus 2gh plus 2gh cosine theta. So I'm going to add these 2 together, the GH cosine theta, so we get 3 GH cosine theta minus 2 GH. And if I factor out GH, we have GH 3 cosine theta minus 2. And I'm going to take the square root of both sides. So we have V on the one end and the square root of that whole thing on the other. And we can go ahead and plug in our values. So we have G 9.81 times our height times 3 cosine of 30 degrees minus 2. And that is equal to 2.3 meters per second.